Alrighty, ladies and gentlemen, we're going to start our new unit here, and you thought that we were going to avoid this for all of time, but no. We are going to do some proofs. It's going to be scary, but you will get through it. I believe in you. I mean, think about it. You guys learned how to use a table saw and a circular saw and sledgehammers and all sorts of fun things, and you got through it. So we're going to make it. All right. So we're going to be proving some triangles congruent. Definitely a little more mathy than applicazioni. All right. There's a few different ways to prove triangles congruent, and we will go through each one. We will also be going over some different notations that you may or may not be familiar with that maybe we've done over the course of the year but never really formally gone over. So pay close attention and take some bueno notes. All right. So we've got our first one, which is side, 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 abbreviated SSS. All it's saying is that we have corresponding sides that are congruent. So we've seen some of this notation, but if you've forgotten about it, it's okay. So this one tick mark means that this side is congruent to this side. So AB, segment AB, is congruent to XZ. Okay. And again, this is much more formal math. So that segment line, that line over the top there, that means we're talking about a segment, right? This is a segment line. This right here is congruent. It's an equal sign with a little tilde on it. That's exciting. All right. And then we could also say that BC and XY are congruent, and then also AC and YZ are congruent. So you'll see those tick marks frequently in these types of problems. It just notates what's congruent. Okay? The next one is side, angle, side, abbreviated as SAS, S-A-S. All right. Well, here I've got AB congruent to FD. I've got BC congruent to ED. And I've got the angle B and angle D congruent. That's what that little arc right there means, is that this angle is congruent to this angle. Okay? So there we go. We've got these two triangles congruent. What types of questions I can ask you is maybe, why are these triangles congruent? Or what else would you need to prove these triangles congruent? And we will practice some of those after we've introduced all of these postulates. The next one, angle, side, angle. As we see, we've got angle T is congruent to angle G. And notice how T is in the middle here and G is in the middle here. That's on purpose. These congruent statements here have to be in that particular order. R, angle R, with the two tick marks, matches up with C, which is why R and C are in the first spot. So then the only place for W and H to go is at the very end. All right. So TR is congruent to CG here. And you can see TR and CG are in the same spots as well. All right. So this is angle, side, angle, abbreviated as ASA. Next one we have is angle, angle, side. So we've got pair of angles congruent, another pair of angles congruent, and then a side, pair of sides congruent. Notice how this is angle, then angle, side, whereas angle, side, angle would have needed this guy right here congruent to this guy right here to get the side between the two angles. So the order in which it's listed, angle, angle, side versus angle, side, angle, those are two different types of things because the order in which they go in the triangle. All right? Woo, we're just cruising through. So which property are we using? So we're going to use probably each one of these, but we just want to identify what property we are using, okay? And I'm also going to introduce a couple new definition, theorem, property type deals that we can use in these situations, okay? So this first one, I have a wonderful question for you. What do you think you know about this angle here and this angle here? Well, those are called vertical angles. Vertical angles. And I'll often abbreviate angles as angles. The angle sign with an apostrophe S, just to save some time, okay? I won't do that right now, though. All right, so those are vertical angles. And what we know about vertical angles, that crisscross situation that we got there, vertical angles are congruent. All right, you can write that down maybe with the picture that we see right there. So with that information, what which one of these four postulates am I using? Which one of these four properties am I using? Well, in this case, I've got a pair of angles here and here, a pair of sides here and here, then another pair of angles that are congruent by our new theorem. Vertical angles are congruent. So angle, then a side, then an angle, bing, bing, bing. It is angle, side, angle. Perfect. All right. Excellent. Wonderful. Fantastic. And what triangles would be congruent to each other? Well, to write that out, I could write triangle, let's just say STR. I'll pick that one. But then the second triangle I need to write in a particular order. Okay? So R needs to be in the same spot as U. Oops. This is what I want to click. Here we go. So R and U have to be in the same spot because they have the one congruent mark. The one where T is, those guys need to be in the same spot. Then S and V, since they have no markings, they would be together as well. All right, so S goes with V, and then we got T goes with T, and then R goes with U. So that would be the congruent statement in which I'd write for those two triangles. Okay, let's try another one. Let's go up to the top right here, and we'll do that one in blue. Well, how are these guys congruent to each other? Well, it looks like I've got a pair of sides, then an included angle, and then another pair of sides. So the two congruent sides form that angle. This is a side angle side situation we got going on. Side angle, there we go, side. All right. And what triangles are congruent? Well, I am just going to start by labeling, let's go with triangle UTR. It's congruent to, and now how does that one match up? Well, U and N match up because they're the congruent angles. Cool. That if I did UT, well, NP is the segment that matches up, so then we got to go with P, and then we'll go with M. Very important that you have those in the correct order. Okay, the order matters on those because it tells us what pieces are congruent to each other, what angles are congruent, what segments are congruent. So the order is very important. All right, our last one here. All right, so this is actually going to have a new property here because I only see two pairs of sides. All I see is AC congruent to BD and BA congruent to DC. So I only see two sides. What else? How about, notice how BC is a side on both of these triangles? That's because BC is congruent to itself by the reflexive property. Okay, so let's jot that down right now and write that in our notes. Reflexive property. Angles and segments are congruent to themselves. That's what the reflexive property is, okay? Any segment is congruent to itself. Any angle is congruent to itself. It's like, well, duh, it's kind of common sense, right? But that is called the reflexive property. That's how we'd get BC congruent to itself. So let's, what we got here is a side situation. Oops. There we go. All right, sometimes the mark gets delayed. And what triangles are congruent to each other? Well, I'm just going to go with triangle A, B, C to start. Right, that's one of my triangles. And then I'm going to match up the second one. So AB, that goes with segment CD, right? Or DC, I'm not sure. Well, AB, and then it would be BC. So I do need to make sure that I go in the same order. Well, D is going to match up, it looks like, with A. And then it would be C. And then B. And let's talk about how I got that. Notice how, so B, or A, B, and then C, it goes from the single dash to the triple dash. I got to do the same thing, single dash to the triple dash, right? If I went single dash to double dash, that'd be the wrong order of things. So that's how I got the order of this guy right here. All right. Woo! Made it to the first ones, right? So that's one type of question, is can you even identify what triangle property we're using, right? And then also maybe can you get a couple other extra little dealios in there, right? Vertical angles are congruent, or reflexive property, which means that any angle is congruent to itself or any segment is congruent to itself. All right, a little more practice with figuring out which property. So what have we got here? Looks like we're looking at these two triangles here. So I've got this side here is congruent to this guy. This side here is congruent to this guy, and these two angles are congruent. But you might notice it's a little bit of a different situation. This angle does not match up in the same position in between these two triangles. So in this first triangle, this angle is between the two congruent sides. But in this triangle, it's an angle side-side situation, which is unfortunately not one of our postulates. Well, not one of our properties, all right? We'll do a demonstration in class as to why you can't use that, all right? So this one is, you can't do it. Nope. So there's just not enough information here. Maybe if there was a little more information, we could potentially prove them congruent. But with what we have, no. All right. Next one. Let's drop down to the bottom here. How are these guys congruent? Well, remember that one reflexive property we talked about with RT? That's congruent to itself. RT, is congruent to RT by reflexive property. So that gives me another side, but I do have two pairs of angles here, right? So the situation I'm dealing with here is angle, side, angle, side. Boom. Angle, side. Angle, side. So that's how these guys are congruent. We won't go over the congruent statements. We'll just figure out why they're congruent. All right, and this next one here. Well, I've got a pair of angles, these two here. Boom, boom. I've got these right angles, but nothing else. I just have two angles. I mean, I guess from that vertical angles, I could prove that these two are congruent, right? But that's angle, angle. That's not one of our ones that we can use. So again, this is a nope situation. Can't prove it. Not enough information to do so. All right, so it's just that one. Lovely. So a couple common misconceptions here, guys. One of them, angle is not a way. It looks like it's saying away. Is not a way to prove triangles congruent. Also, side angle is all right. It is also not a way to prove triangles congruent. Okay, we can't do side angle or angle side. It does not work. Again, we'll talk about that one in person with some little pieces of wood or something. That'd be exciting. Yes. Same type of questions. Again, what property, if any? So I would try these on your own and then hit play on the video, see if you got it right or not. Okay, but if you're still confused, then here we go. Time to explain. All right, this first one, I've got, looks like we got a couple sides here, boom and boom, and then this pair here, and then I got those right angles. And one thing we do know is all right angles are congruent. So those are congruent angles right there. So this would be a side angle side situation. You may want to write this bad boy down as well. All right angles are congruent. Excellent. Duh. If they're right angles, they've got to be congruent because they're 90 degrees. We know congruent means that they are the same measure, right? Same measure whether it's an angle or whether it's a segment length. Okay? Congruent means same. Oop. My marker is going weird. Measure. And that applies to angles and segments. Cool. All right, next one. How about a little reflexive property in here? Give me a side, side, side situation going on. Woo woo. All right. Ooh, number 3. Why are these guys congruent? That's vertical angles are congruent. So now what do I have? I have an angle, then a side, then another angle. Right? That side is between the two pairs of congruent angles, right? This side is between the two angles. This side is between the two angles. Therefore, it's angle, side, angle. And lastly but not leastly, oh my goodness, this one is confusing looking. Everything's overlapped. Let me try to draw these separate, okay? Now, if I have one color, let's go with green. We got this. I'm going to put 2 for this one. This, and then this angle here. Let's see if I can remove this triangle off to the side. Of course not. The whole thing. Okay, well, whatever. We'll just go with different colors. All right, and then I'm going to go with the purple one. Okay, so if I got this, this, and this. So I've got congruent, double, single. Okay, so it looks like I got, if I just draw this one off to the side, it's an angle, side, angle is what we're dealing with. Angle, side, angle on that one. All right. Same type of one. That's exciting stuff. Lovely, wonderful, excellent. Moving on. All right. 6 more. What else could you have wanted? The end of the video? Heck no. Mr. Allen wouldn't disappoint you like that. He finna gonna put in more examples. All right. Here we go. First one. Angle, then a side, then a side. As much as I'd love to be able to do that, we cannot do angle, side, side. It does not work. We are going to talk about that in person. All right. Nope. Next one. Well, looks like I've got this middle side here congruent to itself by reflexive. Remember, any segment is congruent to itself, any angle is congruent to itself. So this ends up being an angle, side, or sorry, not angle, side, angle. Oh my goodness, Mr. Allen. Side, then an angle, then a side. All right, we got sides. Then we've got the angles. Then we got the sides. Cool. M is the midpoint of A, B, and CD. Well, what does that mean? This is something you'll want to write down once again, okay? Because we've talked about these. It's definitely an algebra concept, but also works in geometry. That just means that it splits it in half. So these two would be congruent, and these two would be congruent. So midpoint divides the segment into 2 congruent segments. Divides segment into 2 congruent segments. And I'm going to abbreviate that SEGS because I'm running out of space. All right, so a midpoint divides the segment into 2 congruent segments. So then I can get those 2 pairs of sides. But I need something else. I need a third thing. Ooh, my vertical angles. Pew, pew. Boom. Vertical angles are congruent. I've got side, angle, side happening here. All right. We're going to skip over number 8 here. And let's go on to number 9. Ooh, reflexive property. So this is angle, then a side, then an angle. All right, we've got angles. This guy here and here. Angles. We got that side between. So angle, side, angle. Angle, side, angle. Lovely. And last but not least, I'm going to scooch this up just a little bit. I've got side, angle, side happening. The thing is turned around, but it's still side, angle, side. I got a pair of sides, then an angle, then another side. All right? Those sides form the angle inside angle, side. Side, angle, side. Lovely. Awesome. All right, that was quite a bit there. Hopefully you guys wrote down those definitions. We went over midpoint, splits into two congruent segments, reflexive property, meaning it's congruent to itself, as well as vertical angles. We used all those. All right, that's exciting stuff right there.